Okay. Good day, good people. I'm covering another question on the same paper from the previous video. So it's another geometry, analytical geometry. We did the question with regard to the cycle geometry. Then now we are doing a question with regard to another geometry which illustrate the straight lines there. So you have a straight line F, D, E, and a straight line A, D, B. So in this diagram, we are given that E and F respectively are the X and the Y intercept. So now they're saying E and F are the X and the Y intercept is. So with having the equation Y is equals to 3x plus 8. So this line is Y is equals to 3x plus 8. So now they say the line through B is making an angle of what? Of 45 degrees. With EF as shown below has X and Y intercept A and B, A and M respectively. So it means also the M and the A are the X and the Y intercept. You see? So now here in this regard, they are looking for 4.1. They are looking for the coordinates of E. So now they need the coordinates of E, which is going to be X and Y. So 2 marks. So now let's check. And the E is the X-intercept on this equation, on this line. So we have the equation here. So you just have to do what? The X-intercept there. So Y is equals to 3X plus 8. X-intercept Y is equals to 0. 0 is equals to 3X plus 8. So now transpose 8. So we're going to have 3x is equals to negative 8, isn't it? So now we can divide both sides by 3. By 3, it means x is equals to negative what? 8 over 3. Means the coordinates of E is negative 8 over 3 and 0. Now, you should not forget whatever that you did in 4.1. It will help you to answer the next question. So 4.2. So here they say calculate the size of DAE. So DAE. So they want this angle DAE, this angle. This is what they are looking for. So now look at this triangle. Look at this triangle. We have this triangle. You are going to look at this triangle. Yeah? So this is what you're going to look at. So in triangle, you are going to say in triangle what? DAE. Ne? So firstly, we need to talk about this angle. Ne? We need to talk about this angle. So we have the angle which is ADE. That is equals to 45 degrees. Talking about this angle is 45 degrees. What is the reason there? So we have something like this. So this angle is equals to this angle. What's the reason? It's vertical opposite angles. Vertically opposite angles. Vertical opposite angles. So yeah. So you just have to know the reason. And the reasons like analytical geometry and including geometry. The whole geometry, there's a reason for everything. Everything that you do, you must have a reason. Ne? So now, that's the first point. That's the first point. But look at that triangle. Look at that triangle DAE. So you're looking for that angle A in that triangle ADE, isn't it? So now we can get that angle via what? Via the angle of inclination, because the angle of inclination there is an exterior angle of a triangle. Okay, let me show you how is the exterior angle of a triangle. Remember, we have the triangle is like that triangle. It's like this. We have D here, we have A here, we have E here. So here is then exterior angle. What do you know about exterior angle? It's equal to the sum of opposite interior angles. So it's this angle D plus angle A. You see? Then I said that angle E, or this angle, is an exterior angle, which is an angle of inclination. Why do I say this is an angle of inclination? Look at this is a line there, a straight line there. Then there is an angle of inclination. You see? So now, look, the angle of inclination, we're going to look at that angle. So we are going to use the gradient on this line. So it's tan of what? It's tan of that angle, which is AED. We are looking for that angle. Is equals to the gradient. So the gradient on that line, which is what? Which is equal to 3, because we have the equation of this line, equals to 3. So it means you're going to say second function, tan second function of 3. So it means this will give us how much? Let's see. Second function, so we get an angle there which is 71.557 degrees. So it means we have this angle. So we have this angle. Angle of inclination. We have this angle which is 71.57 degrees. So obviously this, we got this angle here, which we said is 45 degrees. So you're going to do the sum again. The sum of interior angles is equal to the exterior angle. So you're going to say angle DAE, which is this angle, so plus the angle AEDE is equals to the angle AED. Now let's see. So we are looking for this angle, which is DAE, then it's plus angle D, which is 45 degrees, is equals to 71.57 degrees. So now we are looking for this one. So let's transpose angle D and angle A. It will be 71.57 degrees minus 45 degrees. So it means this will give us 26.57 degrees. So we got the answer, 3 marks. got the answer 3 marks. So coming to 4.3, 4.3, they need the equation of AB. So the equation of line AB. So now let's see AB. AB. Now there is a reason there, because look, there's a reason why they ask you this angle. Why? Because the equation that they are looking for is on this line, of which the angle is subtended. That angle is subtended on this line. We just got it, which is 26.57. What is that? Is the angle of inclination on that line. So it means this angle, which is 26.57 degrees, is an angle of inclination. So now we know that is tan of 26.57 is equals to the gradient. There. You see? So it's equals to the gradient. Means the gradient, it will be gradient on that line. It will be how much? So tan of 26.57. It says 0.500. So what is 0.500? It's like 0.5. 0.5 is like 1 over 2. So it means the gradient is 1 over 2. The gradient is 1 over 2. So in that manner, we know the gradient there is y is equals to 1 over 2 x plus c. Substitute any coordinate on that line, AB. We got coordinate of B there, which is 1 and 5. Let's substitute them. Y is 5 is equals to 1 over 2 into 1 plus c. So this is half. 5 minus half is equals to c. So 5 minus half, that's 9 over 2. So it means our C2 will be 9 over 2. So our equation, it will be y is equals to 1 over 2x plus 9 over 2. So now 4.4. Look at 4.4. 4.4, they say AB has an equation of x minus 2 y plus 9 is equals to 0. Determine the equation of D. So now, yes, this is the same as this is what we got. Y. Let's make it in this y, the subject of the formula. It's going to be negative 2y is equals to minus x minus 9. So divide both sides by minus 2, minus 2, minus 2. This will cancel this. Y is equals to x over 2 plus 9 over 2. You see? So this is the same as y is equals to 1 over 2x plus 9 over 2. You can see. So, yeah. Now they say determine the equation of D. So D is on these lines, third line, EDF and also ADB. So now it's a point of intersection. Just equate. You can just equate the two equations. So the first equation it was given, which is 3x plus 8. So we equate it with the another equation that we got, 1 over 2x plus 9 over 2. So equate there, then solve. So it means it's 3x minus 1 over 2x, then it's equals to 9 over 2 minus 8. We just transpose. Take this one that side, this one that side. So it means we're going to say 3 minus half. It will give us 5 over 2. So it's 5 over 2x is equals to, so 9 over 2 minus 8 give us negative 7 over 2. So now we can just divide both sides by 5 over 2. X is equals to negative 7 over 2 divided by 5 over 2. So x will be negative 7 over 5. So now we can get the coordinates of y coordinate because we got x coordinate. So now let's get the y coordinate. So the y coordinate we substitute on any equation. Any equation you can just use y is equals to 3 into negative 7 over 5 plus 8. So y is equals to, let's see, 3 into negative 7 over 5 plus 8. So it's 19 over 5. So yeah, 4 marks. Analytical geometry is it's a beauty. It's a beauty chapter. It's a beauty chapter. You like it? Okay. Calculate the area of a quadrilateral. DMOE. Okay. This is 6 marks. A lot of marks. A lot of marks. So now we have a quadrilateral which is DMOE. So usually with regard to the areas, it's very much important to know the formulas of the properties of the shapes, or the shapes, areas, or especially the areas, the quadrilaterals. So yeah, just know them by heart. But I have sometimes like we have to use must get a secret way of doing things if you don't know the formulas. Because if you see this thing here, let me just try to straight. They're looking for this. They're looking for this. So obviously these come from a trapezium. So it means we have a D, we have M, we have E, we have O. It's like something like that. You see? So now we need to get a perpendicular height here. So the perpendicular height here is somewhere here. It means this is height, then this is A, this is B. So the area, it can be 1 over 2 into A plus B multiplied by the height. So it means it's 1 over 2 multiplied by dm plus EO, so multiplied by the perpendicular height. You see? Yeah, you can use this. It's fine. It's a trapezium. But looking from these, it's a simple way. I'm going to put a simple way of doing this. Because obviously, if you're going to use, this is a formula, just given the formula here. So if you're going to use this formula, it means you must get the distance of dm, the distance of EO, and the distance or perpendicular height there. You see? But a simpler way, look at this. We have a bigger triangle there. So this is a bigger triangle here. You have a bigger triangle here. Then you have a smaller triangle here. So what are they looking for? They are looking for this area, this shaded area. So it means in the bigger if we take the bigger triangle, and minus the smaller triangle, we're going to get the area. So now look at the bigger triangle. So a bigger triangle is A, is triangle what? A, M, O. It's the bigger triangle. So, and we have a smaller triangle, which is A, D, E. So if we say the area, or from the area of a bigger triangle, so if you say the area of a bigger triangle, AMO minus the area of a smaller triangle, triangle ADE. So you're going to remain with this quad. You see? So it means, what do you know about the area of a triangle? It's 1/2 times base times height. So minus 1/2 times base times height, isn't it? Yes. So now it means you can get the distance of MA. Let's get the distance of MA. So remember, you have a coordinate of M there. What is the coordinate of M? Y-intercept. It's the y-intercept of that line, which is on that equation, AB. Equation AB, we got what is it? 9/2. So this is y-intercept. So it means the equation, the coordinates of M, it's 0 and 9/2. So you can see the equation, the coordinates of A. The coordinates of A there, this x-intercept. So x-intercept on the one which equation? On that equation, 1/2 plus 9/2 x, isn't it? On that equation AB. Yes. So x-intercept is 0 is equals to 1/2 x plus 9/2. It means minus 9/2 is equals to, or divide by 1/2 is equals to x. So it's negative 9/2 divided by 1/2. So it's 9. So it means x is equal to negative 9 there. So the coordinates of A is negative 9 and 0. You see? So, yeah. Coordinates of E. Let's look at the coordinates of E. The coordinates of E. What are the coordinates of E there? E, we got them from the first question. Negative 8/3 and 0. So it's negative 8/3 and 0. It's negative 8/3 and 0. So now we can get the distance. We can get the distance from A to O. So from A to O, it's a horizontal distance. It means it's 9 units. So it's 9 units. So from here, from O to M is what? A vertical distance, which is 9/2. So now you can get the distance of what? Of DE. So remember, you got the coordinates of D. You just got the coordinates of D now, which is the coordinates of D. We just got them here, which is negative 7/5 and 19/5. So it's negative 7/5 and 19/5, isn't it? Yes. So now you can get the distance from what? From E to D. So is there a vertical distance. So from here to here, it's going to be 19 over 5. So it's 19 over 5. So it means basically we have the base, the height, distance. Okay, now look, I'm gonna follow this. This formula that I say. It's 1 over 2 multiplied by, what is the base? The base of the bigger triangle is AO, which is 9 units, multiplied by 9, multiplied by perpendicular height. The height will be what? So the height will be MO as the vertical distance, 9 over 2, multiplied by 9 over 2. So minus 1 over 2 times the base of a smaller triangle. Small triangle is what? Let's talk about the smaller triangle. The base of smaller triangle is AE. So AE is the smaller triangle base. So it's 9 units minus what? Minus what is this? 8 over 3. So it means it's 9 minus 8 over 3. So it's 19 over 3. So it's 19 over 3. So it's very, just do the distance formula. If you don't know how to get the distance using the vertical distance and horizontal distance. So it means the base there is 19 over 3. Right there. The height. So the height in this regard is the ED, which is 19 over 5. So 19 over 5. So basically, this will give you 1 over 2 times 9 times 1 over 2 times 9 over 2. So this is 81 over 4 minus, so 1 over 2, so multiply 19 over 3, so multiply 19 over 5. Okay, 19 over 3. To get the solution here, let's say 81. Should I pass it? The difference there, 1 over 2 times 9 over 9 over 9 multiply 9 over 2 minus 1 over 2 times 19 over 3 times 19 over 5. So this give us 8,222 units. So yeah, this is 8,22 units. Yeah, just put the brackets there. I want to calculate. So this is the solution. 8,22 units. Ta-da! I hope you enjoy.